Hi people, welcome back to the next lesson on steel sections and section properties. There we have two steel angles. We call it steel angles. You get two types really. You can see we've got a short leg. We call this a leg, yeah. That's a leg, that's a leg. That's a short leg, that's a long leg. Short leg, long leg. And that we call an unequal leg angle. Unequal leg angle, because the two legs are different length. You can see there. You can see I've written it as 2 times, we write it as a L, or sometimes it's written like this. Means the same thing. That 125 is the distance from there to there, and 75 is the distance from there to there. So that's the length of the long leg, and that's the length of the short leg. And 10 millimeters is the thickness of the leg lengths. So that's 10 and that's 10. Okay, so it's two unequal leg angles, 125 by 75 by 10. If I flick back to the steel tables, which is on blackboard, above that will be there we go, the equal leg angle there. So if I take the top one, for example, it's 80 by 80 by 6. That means that's 80, and it's 6 thick. If I take the next one there, that's 90. If I take that one, and in the third, in that group, notice here, there's groups of them. They just change by leg thicknesses. If I take the third one there, that's 90 by 90 by 10 thick. Okay, and so on and so on. But we're going to do the unequal leg angle, and I've marked my one here, the one that we're going to use in our problem over there. There's it over there. So 125 by 75 by 10. There's 3 in that group, but we're going to, our one is the middle one over there. Okay, so let me just take this off here. And at the top there, we've got a plate. Got a plate there, which is 220 wide by 10 thick. Okay, and notice there, by the way, that's the angle. This bit at the back there, we call it the heel. You know, like the heel of your foot. That's called the heel of the angle. And that bit at the front there, I think you guessed it, is called the toe of the angle. And that's the toe of the angle. Okay, so there's short leg, long leg, thickness of the angle, the heel of the angle, and those are the toes of the angle. Okay, so notice here that the toes of the angles are placed at the corners of the plate there. So from there to there is 220. Okay, right, so people there, as always, the first part of the question is determine the position of the centroid. Now, before we start, do we have any axis of symmetry? Yes, I think we do. It's about the XX or YY axis. Right, now I'm going to draw this axis in, people. Okay. I won't always draw it in. You'll often just get it like this. So I'm going to draw it in so you can see how we draw them in. Right. So the YY axis is going to be sitting somewhere right in the middle over there, like so. And the XX axis is going to be sitting somewhere like so. Okay, so that's the XX axis, and that's the YY axis. Okay, capital X, capital X, capital Y, capital Y. You know the story. And of course, where the two meet there, that's the position of the centroid of the whole cross section. Do we have any axis of symmetry? Yes, we do. We have axis of symmetry about the YY axis. So what does it mean? It means that we're not going to work out x left, x right. We're just going to state it. So x left is equal to x right is equal to the full width of the section. And how wide is the section? The distance from there to there, it is 220. So it's 220 over 2 is equal to 110 millimeters. And there's 2 marks for that. Okay, if you just say x left, x right, just 110 millimeters, I give you 1 mark because I want to see that calculation. I want to see where you got it from. Okay, so people there, that's 2 marks for that there. You don't need to work it out the long way. You can, but you don't need to. You might make a mistake and get it wrong. Right, but we need to work out how far from the top down, from the bottom up. And what did I say there? We always work from the extreme point, so I'm going to work from that point over there, and I'm going to work down. So that means the first point I'm going to get is Y top. So y top is equal to the sum of all of that, of the area multiplied by y over the full cross-section area. Right. I'm going to say that's element 1 and that's element 2. Okay. And I'm going to name that as element 2 as well because they are identical to each other and the distances about the central axis is the same. Okay. So element 1 and these 2 element 2s. Alright, element 1. What is area? It's 220 by 10, so it's 2200. What's y? Y is the distance from the centroid, which is over there. Now let me draw it in quickly. Let me draw it in. Right, there's the y-axis of the plate. Sitting over there. Right, now just let's go back to the table. I'm gonna make this a bit bigger. You need to have your thinking caps on as always. There's my steel angle. And notice there, as in our section here, the long leg is sitting vertically. Can you see that there? The long leg sitting vertically, but in our problem here, it's just the other way around. Okay, there's the vertical and there's the other angle. This one's just sitting the other way around. Okay, so notice there, the x-axis of the angle happens to be parallel to the x-axis of the whole cross section. Okay, is it going in? And the y-axis of the angle just happens to be parallel to the y-axis of the whole cross section. Now, if this angle was lying with rotated to 90 degrees, then the x and y-axis will be sitting oppositely to where they're sitting now. You need to take a note of that. Okay, just make a note of that. Right, so I'm going to draw in the axes of your angle. Right, so it's going to be sitting over there somewhere like so, and it's like so, and the other will be exactly like so because they're identical to each other, and it'll be sitting somewhere like so. Okay, people, I just drew in the x and y axis for our section there, and let me write them in. So that's x, and that's y. I'm not going to do it for the plate. You know that's x and y. Okay, let me write it in. That's x. And of course, the y-axis of the plate is sitting on the y-axis of the whole cross section. Let me just do this quickly and make it. Do that over there. Okay. And the y-axis of the plate is sitting on the y-axis of the whole cross section. So there's the centroid with the angle. And there's the centroid for the plate. And of course, that's the centroid there for the whole cross section. Okay. Right. Let's sort this little baby out here. Right. What's y? Y is the distance from the centroid from there to there. It is 10 over 2, which is 5. You know that now. Plus. Why plus? Because it's the sum of. Right. Area of the angle. Right. Let's go to the tables. There's my... Oops, let me just do this. Let me just bring it down so we can see it. There we go. Right. There's our section. 125 by 75 by 10. I'll go across the table. And there's the area. It is 1910 millimeters squared. Can you see that? 1910 millimeters squared. So it's 1910 millimeters squared times. Right. What's y? Y is the distance from the centroid of the element all the way to the point we taken. Why is it doing that now? To the point to moment of area is about. So how far is it from there to there? Do we know? Not really, but we can work it out. Okay? The distance from the centroid there to the heel of the angle. Are you tuning in? Are you tuning in? I'm going to my tables. I'll just make this a bit bigger. The distance from the centroid, now the centroid of the angle, I'll make it bigger, maybe still more. So there's the center of the angle. It's the distance from the x axis to the heel of the angle. And can you see there, that distance is called AX. So we need to go to the table and pick out AX for our section. And how much is it? It is AX. It's 42.3. Can you see that? It's 42.3 from the center to the heel of the angle. So from there to there is 40, not from there to there, from there to there is 42.3 plus 10 millimeters of the plate. So that is 52.3. You need to get that right. 52.3. Okay. But, are you tuning in? There's two angles. They're sitting at identical positions. They are the same size and everything is identical. They just mirror image of each other. So therefore, I can say this is times a big fat 2. You can put the 2 there or there, doesn't matter. Times 2. Did you see that? If you didn't want to do that, you can also say plus. Again, you can say plus 1910 times 42.3. It's the same thing. Okay. Right. Over the total area of a section. So it's 2200 plus 2 of those. Okay. 2 angles. So I'm going to work on that. Sorry about that. I'm going to say 1910 times 2. It is 3820. Okay. So that times 2 is 3820. And I work it out. Okay, you stop the video, you do the calculation, and you check your answer against my answer, and you see what you get. And what did you get? I got a 35.01. 35.01 millimeters. If you leave it the millimeters, I take up a mark. It's a distance. It's not raisins. It's not fish cakes. It's not Maseratis. Nice car. It's millimeters. Okay. And how do we find y top? Sorry, y bottom. Y bottom is equal to the full depth of the section minus the one we just found. What's the full depth? The full depth is the distance from there all the way up to there. What's the full depth? It's 125 plus 10, which is 135. Take that away from 135. So I'm going to say 135 minus 35.01 is equal to, I get 99 points, almost 100, almost 100. If you wrote 100, it wouldn't be wrong. But let's make it 2 places. Okay, so what does it mean? I'm going to write it in here. It means this, it means that, if I just throw it in, right, so y top is equal to 35.01, 35.01, and y bottom is equal to, we could only made it, if you made it 100, it's okay. If you make it 35, make it 100, I'll accept that, that's okay. Right, there we go. Okay, so y top is the distance from the x-axis to the topmost fiber of that whole section, which is the top of the plate, and y bottom is the distance from the x-axis to the bottommost fiber, which is that over there. Okay, so people, that's the first part of that particular section done. Okay, right, people, next section, the biggie. The biggie. It's not a rapper. No, I think it is a rapper, but no, the biggie. IXX. Right, let's do IXX. Right, IXX. Ooh. Right. State the formula. I give you a mark for it. I big X, big X. Always state the formula because the formula will tell you what you need to look for. Okay. And then I small x plus AH squared. And what's the name of the theorem we're using to a, yes, you know it, Morse, you know it. It's the parallel axis theorem. Right, I'm doing element 1. I'm going to put the equals over here. Element 1. We got the plate. So, do we have tables for the plate like so? No, we don't. We treat it as a rectangle. And what's the formula for the second moment of area of a rectangle? It is BD cubed over 12. What's B? What's D? B is a side parallel to the axis we take in second moment of area back. So B is 220 and D is 10. So it's 220 times 10 cubed over 12 plus the area. The area is 2200. What's H? You know what H is. H is the distance from the centroid of the element to the centroid of the whole cross section. Did you get that? You need to learn that. If you learn that and you memorize it, you will know what to look for. H is the distance from the centroid of the element to the centroid of the whole cross section. Can we work at it? Yes, we can. It's y top take away 5. Okay, it's y top minus 5. So it's 30.01. 30.01 squared plus. Why plus? Because the formula says plus. Oh, that's element 1. I forgot to put in. Doesn't matter, but just to tell me. Element 2. Right. Now, notice there, the x-axis of the steel angle is parallel to the x-axis. So we go to the steel table and we go to that one over there and we go to about IXX and we go to I. So that's IXX and we go down there and it is 3.02 times 10 to the power 6 millimeters to the fourth. Okay, you need to get it right. 3.02. So it is 3.02 times 10 to the power 6. If you leave that bit out there, it's going to be wrong. You know that now. Plus the area. What's the area? I forget the area again. The area is 1910. Here we go. The area is 1910. 1910 times. What's H? H is the distance. Let me change the color here. Let me make it a nice pinky color. H is the distance from the centroid of the element to the centroid of the whole cross section. Did you see that? It's that distance over there. Did you get that? It's the distance from there to there. So, can we work it out? Of course we can. Okay? We got y bottom. That's why we work it out. So, y bottom minus that distance over there. But do we know that? No, we don't. But we know the distance from there to there, which is how much? I think, if I remember correctly, it is AX, which is 42.3, which is, there we go. Okay, so from there to there is 42.3. So, of course, from there to there is 125 minus 42.3. We take that away from y bottom and we get H for the angle. I'm going to work it out now and check me. Okay, so it is 125, take away 42.3. It's equal to 82.7. I'm going to take 125 away and I get 42.30. Okay. Oh, is that right? Hang on. Let me check mine again. Right, so from there to this 42.3, I take that away from 125. So I get the distance over there. And then I take that distance away from this and I get 17.29, which is what you should have gotten. 17. Okay, I'll leave it as pink color so you can see where it belongs to. Squared. But people, but, there's two of them and they're identical in every way. So you can either say plus and write another bracket in, or you can put a nice big fat 2 in front there. And that will be the same thing. Okay, and now I'm going to say is equal to, give me the blue again, there we go, is equal to, right, do the calculation and check me out. Okay, and I'm going to do it and I'm do the calculation, and what did I get? I got 9 point, oh, horrible, oh, man, 9.182 times 10 to the power 6, and put the units in, others that take a mark of millimeters to the fourth. There we go. Okay, so it's 9.182 times 10 to the power 6. Okay, right, people, so that's IXX. Now we need to work at IYY. Okay, let me just clean this up quickly here. Right, IYY. IYY, big Y is equal to the sum of, using the parallel axis theorem, I small y, you know why that's the case, plus AH squared. Right, element 1. It's a plate. We treat it like a rectangle. It's BD cubed over 12, so it's 10 times 220 cubed, because B is parallel to the YY axis. 10 times 220 cubed over 12 plus its area. Man, what's the area? 2200 times. What's H? H is the distance from the centroid of the element to the centroid of the whole cross section, but the YY axis of the plate falls on the YY axis of the whole cross section, so H is naught for this one, and that term falls away. And you know what a lot of students do? They give it a value because they see a value and you get it wrong. Okay, it's naught for the plate. For the plate. Okay, plus. Why am I so skewed today? Right, so what do? I go to the tables and I pull out the IYY of the angle section. So it is, there's YY, there's I, it is 0.821 times 10 to the power 6. It is 0.821 times 10 to the power 6 millimeters to the fourth, plus its area, which is 1910, I seem to remember, times. What's H? Are you tuning in? H is the distance from the centroid of the element to the line we take to the, H is the distance from the centroid of the element to the centroid of the whole cross section. It's also equal to that, as you can see. Yeah, it's the same. Okay, so H is the distance from the centroid of the element to the centroid of the whole cross section. And can we work at it? Yes, we can. What we're going to do, we're going to go to the tables and we're going to work at the distance from there to there. Okay, did you see that? From there to there, from there to there. And if we go to the tables, that distance is called AY. Did you see that? We need the distance from the centroid to the heel of the angle horizontally, and it's called AY. And what's AY for our angle section? It is 17.6 millimeters. Did you see that? Okay, but it's 17.6 from there to there, plus the distance from there to there. And how far is it from there to there? Are you thinking? Right. From there to there is 220. And from there to there is 75. 75. So what's the distance from there to there? So what's the gap between the two of them? It is 70 millimeters. So from the back, the heel of the angle to the YY axis, it is 35. Okay, so 17.6 to there plus 35. I'm working it out. 17.6 plus 35 is equal to, it is equal to 52.60. You need to get that right. Okay, it's 52.60. 52. Squared is equal to, I'll explain it again. H for the angle is distance from there to there, but from there to there is AY from the tables plus half of the gap, which is 70. So it's 17.6 plus 35 gives you 52.60. Alright, and you work. Oh yes, I almost forgot. There's two angles. They are identical. So we can put a nice big fat 2 in front. Because they're identical in every way. And they mirror image from each other. And the distance from the centroids to there is exactly the same. So I can say 2 of that. I work it all out. Stop the video and check the answer for yourself. And I got 2.108 times 10 to the power 7 millimeters to the fourth. Write the units in. Why am I doing that? Write the units in, otherwise I take up a mark. Okay, so people, that's IYY. It's 2.108 times 10 to the power 7 millimeters to the fourth. Okay, so what we're going to do next, we're going to do ZXX top, ZXX bottom, work at R-min, and that one is history. Okay, let me just clear the board quickly. Right, people, the question says work at ZXX, and of course there's 2. Okay, so ZXX with respect to the topmost fiber is equal to IXX over Y top, and IXX is equal to 9.182, 9.182 times 10 to the power 6 over Y top, which is 35.01, 35.01, and that is equal to, I get 2.623, 2.623 times 10 to the power 5. And what's the units? If you leave it out, I take a mark off. It's not millimeters, it's not millimeters squared, it's not millimeters to the fourth, it's millimeters cubed. It's not a volume, but it pans out as millimeters cubed. Okay, right, and ZXX with regard to the bottommost fiber is equal to IXX over Y bottom. IXX over Y bottom, which is that over there, 9.182 times 10 to the power 6. Y bottom is just a shade over 100 or under. And I get that there. Don't write it down. Do the calculation yourself. That's how you practice and learn. Check your answers against mine. And I get, what did I get? I got 9.183. 9.183. Looks like a snail. Times 10 to the power 4 millimeters cubed. Okay. And then finally, R-min. Let me do it over here. R-min, I'll say E. R-min. What is R-min? R-min is the smaller of the two I values divided by the total area. And what's the smaller of the two areas? Of the small I values? Which is smaller, IXX or IYY? It is IXX in this case. So that means this beam is stronger about the YY axis because the IYY value is bigger than the IXX. Not often the case, but in this particular case it is. So the smaller I value is IXX, so it's IXX over the total area, the square root of the lot. And what's IXX? It is 9.182, 9.182 times 10 to the power 6 over the total area. And the total area, I think, was, how much, let me work it out quickly. And the total cross-section area, I think, is 6020, 6020 millimeters squared. So it's the square root of the whole one. Okay. And I get about 39.05 millimeters. Okay. So if you get 39.1, or if you get 40, or if you get 38.7, that's okay. That's all the rounding off as you go. So people, that's R-min. Okay. If you work at IYY over the total area, you get a slightly larger answer because IYY is bigger than IXX, but it will not be R-min. So get it right. Okay, people. There, I took another compound section which had symmetry about the YY axis. So therefore x left was equal to x right, and I worked at I y top, y bottom. We worked at IXX, we work at IYY, we work at the section modulus with respect to the top and bottom axis. We didn't do ZYY, which will be respect to the X left and X right fibers, and we worked at Armin. Okay, people, that's all the sections I'm going to work out. So the next thing I'm going to do, be posting on here, is the exercise I want you to do. It's in the core notes there, work it out. I'll say some things about it, about some of the sections in there, because some sections are a little bit old. The sizes are slightly out from sections that's manufactured today. But yeah, people, that's the end of the lessons on section properties. I've done the concrete ones with voids and various shapes, and I've done 2 steel compound sections with plates, without plates, with channels, eye sections, etc. You need to do all the rest, and like I've been saying since the plow mechanics days, you need to work at all the problems I give you all the answers. You work it out until you get the answers. If you have any questions, send me an email, and I'll try and get back to you as soon as I can. Okay, people, I'll see you in the next video.